Okay, welcome to Tuesday, week, what are we, week 7 already? Week 8? How do I not know this? I've been at too many meetings. Week 7, yeah, Tuesday, week 7, level C math. We're moving on. Homework questions seem to be done for now. Last time we did proportions with variables, or proportions and cross multiplying and then putting variables in. Now we're adding word problems. So if they come out of word problems, then sometimes we make the proportions correctly and sometimes we don't. So here are 4 different word problems. And I'm wanting you to tell me about which ones are right and wrong for each. So for number 1, there's 4 different colors. It turns out 2 of these are right and 2 of them are wrong. And for number 2, again, 2 of them are right and 2 of them are wrong. So which ones work in each of these cases, and how do you know that? I'm not going to pause it because if you're watching this from home, you also should sort of stare at it for a while and figure this out yourself.
Should we be answering?
Yep, if you notice something, let me know.
Number 1, the first 40 miles over an hour, 80 miles over 2 hours. That's correct.
Okay, so we have a vote that that one is good. How about the blue one?
I don't think so.
You don't think so? Okay, so we'll put an X on that one. Don't write this on your paper if you're taking notes. I am not affirming that these are right or wrong. I'm just recording your responses.
I would say the next one's right.
You want the next one right? Okay. And so if I said that it's half and half, then you're guessing this one is wrong as a group. Okay, somebody explain why they think the red one is correct. And we'll see if it really is or not.
It just looks right. If it's 40 miles in an hour, that's 40 miles over 1 hour. And then 2 hours would be 80 miles over 2 hours.
Okay, I like what Cheryl says. I'm going to be teachery. I'm going to say that 40 miles in an hour is one situation. And I'm going to put arrows on it, that we're doing miles first and then hour as we talk about it. And similarly, 80 miles in 2 hours is a situation. And we are mentioning those. And it's symmetric. On both of them, we have the miles first and the hours second. We have one situation on one side and the other situation on the other side. So to paraphrase Cheryl, yes, that looks right. It seems nice and symmetric and organized. Does it work for cross multiplying? Is 40 times 2 the same as 80 times 1?
Yes.
Yes, so that checks out also. So we're pretty sure that this is right. It looks nice, it's symmetrical, the cross multiplying checks out as true. So, okay, that one I'm going to safely say, yes, that's definitely a good way to do it. How about blue?
I believe that one's wrong.
I'm going to remove the X that's in the middle so I can draw my arrows. If we have the first situation, 40 miles, 1 hour, and the second situation, 80 miles and 2 hours. So it is still symmetric, but now one situation is on the top and the other is on the bottom, instead of one being on the left and the other being on the right. Does the cross multiplying work? Does 40 times 2 equal 80 times 1?
Yeah.
Yeah. So this one is, for most people, very unnatural. They don't like it. It is not surprising that people pick the first one instead. But this is actually an okay way to do it. And there are some people that will, the way their brain works, they will want to put one situation on the top and the other on the bottom. I will never do that. My job as the lecturer is to make it friendly to the most people, and I will do it where one is on one side and the other is on the other side, because if I write it this way, everyone makes faces at me. But if you write it this way, there's nothing wrong with that. You can put situations on the top and bottom as long as kind of the directions are parallel. If miles is on one first, it has to be on the other first. So that one's actually okay, but admittedly, for most of our brains, quite awkward. How about the third one?
That just looks all wrong to me.
We can check the cross multiplying. Is 40 times 80 the same as 1 times 2?
Nope.
No, so that disqualifies it. Let's look at the arrows. 40 miles in 1 hour, 80 miles in 2 hours. So we still have the situations, one on the left and one on the right, but now they're going in the wrong directions. They're not symmetrical anymore. And that's what makes the math not work. 40 times 80 is not 2 times 1. So this is wrong. Red is wrong also. Is 40 times 1 the same as 80 times 2? No, so that disqualifies it. Let's see where the arrows are. 40 and 1, 80 and 2. So this is like evil things in Ghostbusters. You don't want to cross beams. You're not organized that way. So we're getting some lessons. It's easiest for almost everyone if you have it one situation on the left, the other situation on the right, and they go the same sort of direction, so to speak. If miles comes first, it's first both times. If hours is second, it's second both times. Okay, let's look at number 2. Now that we've talked about all of that, which ones work in number 2?
I believe the first one's wrong.
The first one is wrong.
And the two in the middle
12
right.
times 36 is not 3 times 1.
And then I believe the two in the middle are right.
2 in the middle, all right. So you think this one's wrong. 12 times 1 is 36 times 3. Oh, that's not going to work. Let's check our arrows. 12 tests in 1 hour. 36 tests in 3 hours. So yes, both of the ones in the middle work. This is the one that probably looks the best to you, because again, most people like one situation on the left, the other situation on the right, and they're symmetrical as far as which words are on top and bottom. My smiley faces are having trouble today. Do you want me to do the arrows for the ones that don't work so we can see how the arrows mess up, or does that just make the page too busy?
I'm good.
I'm good.
Okay, number 3, which ones are good?
The first one's right.
The first one's right. Is 220 times 5 the same as 11 times 1? That checks out. Let's do our arrows. 220 for 1, oops, 220 for 1 pound. 5 pounds costs 11. Oops. So yeah, that one they word it. Let me do this right. So 11 cost 5 pounds. The arrow is facing the other way in the word problem. Here, it's true that dollars is always on the top and pounds is always on the bottom. So they tried to trick us. They put things in the wrong order on the second sentence. It's not dollars first and then pounds both times. But when we make our equation, we want dollars to always match on the top and pounds to always match on the bottom. We could have flipped both of them. You could put pounds on top both sides and dollars on the bottom both sides. That would be fine, as long as it's consistent, as long as it's symmetrical. Okay, blue one.
That one's wrong.
That one's wrong. 2 times 11 is a lot more than 5. Oops. Green one.
Right?
It is right. This is the right but awkward one. Oops. $2 for 1 pound, or 220 for 1 pound. This has one situation on top, one on the bottom. They are symmetrical, but again, this looks odd for most people. The first one just seems better. Okay, and the last one, 220 times 1 is 11 times 5. No. Okay, we're almost done. Number 4. There are 260 weekdays in a year, by the way. That's why this has the 260.
I believe the last 2 are correct.
Okay, let's check with our arrows. So 175 each day. Well, that's not going to work. It's diagonal. 455 every 260 days. So yes, you are correct. This one, they go opposite directions. It's not symmetrical. Dollars is on the top on one, but the bottom of the other. This one, they cross beams. Ghostbusters doesn't like that. And the other 2 are the correct ones. This one is what most people like, where one situation is left and the other is right. The last one is valid, but for most of us looks awkward. Any questions about the whole slide?
I'm good.
How is number 4 trying to trick us?
By not counting all the days?
Yeah, we want dollars and days, but neither sentence had the word days in it. this one said weekday morning, this one said per year. So we had to sort of take both of those and make it into something that could fit on both proportions. So a big moral of the story is don't rush this and leave off the labels. If you just put 4 numbers on a proportion, 12, 1, 36, 3, it's too easy to do it one of the wrong ways and not notice it. It's the words that tell you that everything is symmetrical and reliable or not. Okay, but that's it. So now we can just do a bunch of them. Our job for these are always the same. They are nice and consistent. Is that big enough font, by the way? That looks small to me.
I can see it.
I'd like it a little bigger, please.
Here, I think I should make it bigger because some people will be watching this on their phones and like that. Okay. One brand of microwave popcorn has 120 calories per serving. So how I do these problems is I read through it once. A whole bag of this popcorn has 3.5 servings. How many calories are in the whole bag? So I've noticed 2 things as I read through this problem. First, that it has 2 situations. One situation up here, and the other is the whole bag, right? 1 serving, whole bag. The other thing I've noticed is they've given me 3 numbers, calories, 1 serving, 3 servings, and they're asking me for a 4th, how many calories? So those are the clues that this is a proportion word problem. There's 2 situations. So I'm going to put situation 1 on one side. And situation 2 on the other, just like we talked about. And they gave me 3 numbers and asked for a 4th. So 120 calories every 1 serving. And how many calories are in 3.5 servings? Everyone okay with my setting things up?
Yes.
So calories stays on top, serving stays on the bottom. Could I have flipped everything? Yes. If you wrote this 1 serving is 120 calories. So 3.5 servings is how many calories? There's nothing wrong with that. So most people will write it the same way, just because sort of as the sentence goes from left to right, that's how you label your first thing. But it's not wrong if you flip things, as long as it's consistent. If I have servings on the top once, I have to have the other servings on the top also. So keep your words parallel, everything will work out. So I will just write over here also. Yeah, let's start. Okay, but back to what I've written in the black area here. So I've set up my proportion. I have turned a paragraph into a proportion. What do I do next?
I would just multiply.
Yeah, so I do my cross multiply. Remember, I have a few superpowers. It doesn't matter what goes on the left or right of the equal sign. So I will always first do the diagonal that has the letter. And when I multiply 2 things, it doesn't matter which I put on the left or the right. 3 times 5 is the same as 5 times 3. So I will always pick the letter first as I'm picking things. Okay, then I multiply the other way, 120 times 3.5. Again, it doesn't matter which order I write it in. Oops, I am failing my color coding. Let me make the y times 1 blue. So I always get something that says y times something else equals some other thing. And I know how to do those. Y times 1 is just y. 120 times 3.5. Open up my calculator because I'm tired. I've been at Zoom all day. So 420. There we are. And I'm not quite done because this is a word problem. So I need to label my answer. What am I doing? Calories. So far, so good.
Yeah.
Okay, let's do a whole lot of these. I'm going to shrink this one a little bit just so I can copy it nicely. Okay. So if this wasn't in the proportions chapter, I would read through it first to make sure it's a proportions problem, because maybe it's something else like a scaling problem or an area problem or something. So pediatricians are prescribing some medicine for 5 mils. It's a 25-pound kid. A different kid has this many pounds. How many mils? Yes, so I have 2 situations. They give me 3 numbers and they ask for a 4th number. So it's this kind of problem. The first situation has what things to write down?
5 milliliters over 25 pounds.
Yeah. And the second situation has 80 pounds. And I don't know how many mils. Everyone okay with my setup?
Yes.
So then we just charge into cross multiplying because we know how to do that. So y times 25 . 5 times 80. So 5 times 8 is 40 with an extra 0 afterwards, so 400. I have one of these one-step equations. Something is stuck onto y with times 25. How do I get that off?
Divide by 25.
Divide by 25. So how many quarters are in $4?
16.
16. And then this is mils, right? Up here, y is mils. Questions about that one?
I'm good.
I'm good here. Thank
Okay. I am writing more than you need to. I'm going to start talking about that. So I write a lot because I'm lecturing. I don't want you to necessarily waste lots of time doing homework. So let's talk about the writing things with this one. Susie can read 12 pages in 16 minutes. That's one situation. How many pages can she read in 5 hours? That's the other situation. Lucky Susie gets to have a 5-hour time for reading. That would be nice. Okay, so one situation, 12 pages, 16 minutes. The other situation, I have no idea how many pages. Oh, 5 hours. Can I put hours here?
No.
No, my words have to match. So I either have to make minutes into hours or hours into minutes. What's the easier one to do?
Into minutes.
Hours into minutes, okay. So I will catch myself, not make that mistake, and say 5 hours, I'll cross that out, and how many minutes will that be?
300.
Yeah, so 5 times 60 minutes, because each hour is 60, and I get 300 minutes. Everyone okay with my setup?
Yes.
So we dive on in. Y times 16. Oops. 12 times 300. Okay. Last time I wrote 2 different lines, one in black and one in yellow. The first line I wrote was, let's combine the 5 times 80 to get one number, because that looks nice. Y times something equals something else. Then in yellow, I said, let's get Y by itself. You don't have to write both. If somebody is reading your work, they can understand what you do. If you just say, for example, I'm going to divide both sides by 16. That would tell them that what's happening on this side, the 16s are canceling out, times 16 divided by 16 doesn't do anything. And on the other side, 12 times 300 divided by 16. So 225. I don't have to actually know that 12 times 300 is 3,600. I can just do those 3. Everyone okay with that?
Yeah.
I also could say, I don't want to write what's in yellow, I just want to write in black. Not that you will necessarily use my colors. Then it's also clear what's happening. On this step, I put those together. And then on the next step, I divided by 16 both times. So that's okay too. If you leave out both, then that's not polite. That's just sort of kind of saying, I did my cross multiplying step and then magic happens, I know what Y is. Do you see how we're skipping too much here?
Yeah.
So this won't help you as much when you're studying for the final. This won't help you work in a group, and whoever is working with you, whether it's a friend or family member or classmate, they won't be able to see what you're doing. So this is skipping too much. So I would at the very least write one of those things. And if you are going on to Math 60 or something equivalent to that, I would encourage you to actually write all 4 steps. It will build up some good habits for Math 60 that I don't want to talk about now. That would just be getting to Math 60 stuff and distracting us. But it doesn't take that long to write both middle steps. And if you're not stopping with the GED, but going on to other math classes, then this is worth doing. It's okay. But if all you write in our class is something like that, then great, that's good enough. Does anyone know a shortcut where you don't even have to write this much?
I do.
tell me your shortcut. Let's use it on the next one. So let me get the, okay. So before, knowing this is a proportion problem, before I even start, I will write sort of my skeleton, fraction bar equal fraction bar. I'm going to start reading. Scott can do 3 problems in 11 minutes. And then knowing it's a proportion problem, I'm going to stop reading the problem. I don't care what the rest says. It has to have problems on the top and minutes on the bottom. I will put that in right away so it doesn't trick me like it tried to last time. Does that make sense? Then
Yeah.
I keep reading. How long would it take? Minutes is the thing I don't know. To finish a test with 20 problems. Okay, now tell me your special shortcut.
Um, $20 times 11 divided by 3.
Yes, you take the 2 numbers that are opposite each other and you multiply those. And then you take the 1 number that's opposite the letter and you divide by that one. So you could jump right to y equals 11 times 20 divided by 3. Do that on a calculator and get about 73. So if you know that shortcut, you can use it. Let's look at why it works. Why are we multiplying the 2 numbers that aren't opposite y? What's happening there? Describe it on this slide.
I just use it as a fraction. I'm not exactly sure how to explain it.
Where are they on this picture? I'm looking for the 2 numbers that don't have a y as I'm doing their diagonal.
Oh, 12 and 300.
12 and 300. I put them in green this time. Did I put them in green on that one?
Yeah.
Yeah. Did I put them in green on this one? Yeah.
Yeah.
Since I'm always starting with the blue and picking that the blue has the y, then the green side always has the 2 numbers that don't have the y. Just because they're left over, I've picked the side with the y first. So I multiply those. And then where's the divide by the one opposite y? That's because something always gets stuck onto y with times. So to undo that, I do divide by that thing. So I'm dividing by the thing opposite y. I divide by the 16. I divide by the 25, right? I divide by, in this case, 1. That didn't do anything. So that's why this shortcut works. Multiply those and divide by that one. If you're using a shortcut a lot, you're not getting some good algebra practice though. And the GED has lots of this kind of problem. So since you are GED students and perhaps going on to more math after that, I would, as much as possible, avoid using the shortcut. If somebody was to ask you to do a page of 50 of these, yeah, it's going to get really boring and you're going to start using shortcuts. But I'm not going to make you do that many of them. So kind of understand the shortcut, use it maybe, but the more you don't use it, the more you'll get good practice for a kind of algebra isn't scary. I can do this kind of stuff. It gets quick for me. The GED will be easier. Okay, questions about any of that?
I'm good.
No.
Okay, well, let's do more of these. Oops. Fit on the page better. So again, somebody's told me this is a proportion problem, so I'm not even going to finish reading it. 8 feet of a certain kind of board. Does it matter that this 2 and the 10 is there? No, that's a distraction. Costs $14.49. Uh-oh, I have a decimal. Does that bother me? No, the calculator is doing all the work anyway. I'm going to write my $ on this side because when I'm doing these proportions, I want things to match, and it's just easier if all my labels are on the right of my numbers. It looks nicer. Then I stop reading. I need feet on the top and dollars on the bottom. Then I keep reading. How much will it cost? So that's my unknown to get 158 of this stuff. Everyone okay with my setup?
Yeah.
Yeah.
Okay, someone do the shortcut and we'll see if we get the same answer. As I warned you last time, once you get decimals, just be a little wary because you don't want the multiply dot and the decimal dot to mess up yourself. So what's 14.49 times 158? 2354.2. And I'll divide both sides by 8. Again, I am writing lots. You don't have to. If you write even, about 294.28. So you can leave out either of these steps and still be getting plenty of algebra practice for the GED in Math 60. Does that match what you did?
No, somehow it did not.
Okay.
Me either.
Maybe I typed in wrong. Oops, it was me. 1449. 2289. 158. Yeah. 2289.42. And then my answer should be what? 286.18. Is that better?
Yes.
Okay. That's what I get for trying to use a calculator with my little pen. 286.18. Okay. Yay, now we're good. And that's really all I can talk about these. So we can do more of them if you want. If you feel ready for homework, then we can be done for now. There's more example problems going on. 53 and 54 are your challenge problems. At the beginning of a study, there's fish that are caught and tagged and thrown back. And then we catch them again. It's easy to see some situations but this is really a tricky problem. And the trickiness comes from the fact that you want to write something where all of the labels are fish. And if all of your 4 labels are the same, then you have no idea if you've put the numbers in the right place. It doesn't help to check if the words match on the top or the bottom if they're all the same. So you can't have everything be fish. So the trickiness of 53 and 54 is to invent labels that make sense so that the top and bottom are have distinct words, and you can tell if you're turning one thing upside down or not, or if they really match. Okay, I don't have any videos for this, which is unusual. I will put a note to myself. I should try and get you some videos. Sure, there are some out there. Okay, do you want to do number 52, or are we good for homework readiness?
I think I'm homework ready.
Me too.
Okay, well, the answer's there if you need to peek at it later. I want to talk about how we know 3 different ways to do the same thing. So let's talk about that. I will clear this. You are not responsible for being able to do all of these equally quickly. Some people will like one of them a lot more than the other. But you are smart math students who pay attention and should realize that you have 3 ways to do this problem. Some people like to find a unit rate. If it's true that it's 36 feet in 1.8 minutes, I can do top divided by bottom. That changes any fraction or rate into a decimal. So what is 36 divided by 1.8? 20. So this bug is going 20 feet per minute. Then, how many feet would it crawl in 12 minutes? What do I do?
20 times 12.
Yeah, 20 feet per minute times my 12 minutes. Minutes is minutes over 1. This is like unit analysis. If you want to think about it this way, a minute on top and bottom will cancel. All that's left is feet. If you don't want to think about it that way, that's fine too, but it works. Anyway, 240 feet. Some people really like that, and that's how they would always do it. Other people like the unit analysis. A bug crawls 36 feet in 1.8 minutes. How many feet would it crawl in 12 minutes? I'm going to multiply it by a fraction. Minutes was on top, so I should put my minutes for the next thing. I'm sorry, minutes was on the bottom, so I should put my minutes for the next one on top. 12 minutes over 1. And actually, let me back up. I'm explaining that backwards compared to what I did a few days ago. No, I'm not. This is good enough. I'm going to confuse you if I try and correct myself. And we'll get 36 times 12. $432. The minutes cancel. Finish up unit analysis with top divided by bottom. And we will get the same answer as before, 240 feet. This one is very rarely what people pick for this kind of problem. Unit analysis you need to use when you have lots of different conversions that happen one after another. We've seen that. But if you only need one and it's a situation instead of like a measurement unit conversion, feet to inches or something, then this just seems more awkward. People don't tend to pick it, but you could use it if you want. And lastly, what we just did for the first time today. You could use a proportion. Fraction bar equals fraction bar. The first situation is 36 feet in 1.8 minutes. How many feet in 12 minutes? Before I go on, check. Feet on the top, minutes on the bottom. Good, good, everything's symmetric. Y times 1.8. 12 times 36. I will model writing less than I did before. So you don't have to write as much as I do before. So 36 times 12 divided by 1.8, and we'll get the same 240 that we did before. So this one is also popular. Most people pick the proportion way or the unit rate way. Questions about that?
No.
Okay. So I tell you this, that if you see a bunch of problems like this on homework or a test, then if you do them one way, you like proportions, and someone else does them another way, they like the unit rate, that's okay. It's not like there's only one way to do these. No one's going to mark you wrong for somehow picking the wrong method. Okay, I want to show you about scale factors. Oops. I could take some of these equations, some of these proportions. 40 miles in 1 hour is the same as 80 miles in 2 hours. A parking meter costs 25 cents for 15 minutes. It costs 75 cents for 45 minutes. And make a different shape. Instead of making an X shape like we have been, I could go from one side to the other saying, oh, I recognize this. I am just unreducing fractions, right? It's a times 2 top and bottom, or it's a times 3 top and bottom. So if you notice that, that works. If someone gives you a problem, 40 miles in 1 hour is how many miles in 2 hours, you can say, I'm going to do it like this kind of shape. This is a times 2. So this also has to be a times 2. And 40 times 2 is 80. That one is less reliable as a method to use in most occasions because you often just can't quite see what it is. Right? 1.8 times something is 12, but it's not obvious what that is. Eight times something is 158, but that doesn't look friendly. Right? So this tends not to be something that is useful as a tool for solving these, compared to the other 3 methods we just did. But occasionally the numbers are just really friendly and you can see what's happening. And if that's how you do it, great, that works too. There are some examples that are just kind of stereotypically done thinking about scale factors. If you like that, then we can do that, but I'm going to skip that for now. Pictures are another example of when people like to use the scale factor type of thinking. Okay, here's a bunch of those good videos that we didn't have earlier. So you do have lots of them. Let's look at the homework for this topic. The first 2 are checking that ratios are true. They're writing them this way to confuse you, not as one number on top of another, but you could write these as fractions and do your cross multiplying. Then we jump into lots of word problems. And the tricky ones are a little tricky. It's checking about unit rates to make sure that you haven't lost your brain thinking about unit rates just because we're suddenly talking about cross multiplying. I warned you before that once we do cross multiplying, some people try to cross multiply everywhere, even when it's not a cross multiplying problem, when it's not one situation equals another situation with matching labels on the top and the bottom. So these are trap problems, number 8 and number 9. Don't cross multiply there. And then number 10 is the challenge problem. Most homeworks, as you've noticed, have number 10 be really hard. So the forest ranger is catching some deer and tagging them and releasing them. And if you try and make a proportion with all 4 words, just deer, then that's not going to work well. You need some other label other than just the word deer, or you don't know if your number's in the right spots. Other than that, this should be straightforward because we just did a whole bunch of them. The random exercises have some stuff we did at the top of this topic for 1-step equations. A check if a proportion is true. One that's not a word problem. Again, don't use this diagonal icky format. Make it like straight up and down above each other so the X's work better. Some word problems, and then one that is phrased as a scale factor, but it's the same thing as these others. It's just phrased slightly differently. Are there any of H or I or J or K that you want me to do while we're on the word problem theme?
I'm good.
Okay, I don't trust you. Let's do J. J has a trick at the end. See if we can not be tricked by it. Okay, so fraction bar equals fraction bar. A college is expanding from that many students to that many students. Right now it has 17 instructors. That's a really small college. How many more does it have to hire to have the same student to faculty ratio? So what do I put in the now situation? And what do I put in the future situation?
$357 would be now.
Okay, and I want a label for it. So students. And then whatever I do, I know that students has to be on the top also on the other side. Okay, then what?
And then 2,226.
Okay,
And then the 17 goes under 357 instructor.
then I don't know how many instructors are over there. Okay, so far so good. Cross multiply. Oops, I'm supposed to do that one in blue. Does it help if I write both lines here, first condensing these into one number and then division, or should I just put the division right there?
You can just put the division right there.
So y will be by itself. 17 times 2226. Make sure I don't have any typos this time. Divided by 357. Get 106. So that's not the answer. Read things carefully and tell me what I have to do.
Would you do 106 minus 17?
Yeah, it doesn't ask for how many instructors will there be. It says how many more.
That was very tricky.
It was, which is why I'm friendly and pointing it out before you try it. So that's about the only way these can get hard, is if either they don't give you the same words, like one is hours and one is minutes, or at the end, they try and trip you up and they don't actually ask for this number, they ask for you to do something with that number. But in this class, you get practice tests, right? When you go to the justice overall test, then all these problems, you'll be able to do as many versions as you want. You'll see how they change and how they don't. So they will not try and trick you in any new ways when the real final happens. So. Notice my good habits. I keep my Y's lined up. I keep my equal signs lined up. I keep this stuff lined up as much as I can. I don't usually put a box around my Y. I just put a box around the 240. Why would that be?
Because that's the number the Y turned into?
Yeah, the Y is like my own private stuff. Whoever gave me this, my boss at the job or whatever, I don't know. They don't know what Y is. That's just a number I made up. I could have used X or W or Bob or whatever, right? So that's just a name for something I don't know. They don't care what I named the thing I don't know. They just want the answer. So that's why I put my box here instead of the whole bottom line. Okay, and we are done. That's everything there is about the fractions part of equations. It's a little after 7. Do you want a little break and then we'll do percentages? Do you want to keep going and then sort of have the homework time at the end? Do you want both because you need to deal with kids for a moment and then we'll keep going?
Works.
I'd like those, please.
I'm sorry, say it louder.
I'd like both, please.
Both, please. Okay, let's take a 5-minute break now. And if you're not back in 5 minutes, then we'll wait for you and we'll keep going. Percents sometimes is easy and sometimes it's not. It depends on your own math background. Did you have a good math teacher or not in your past? No shame on you if this is quick or not quick. It's not really about you. So this is something that we might get all the way through today, but I doubt it. And if so, we're not going to get all the way through it in any final way. Well, lots of people will need it more than once. So that's a heads up. Okay, see you soon. I will pause recording. Okay, after the break, we're doing percentages. We're talking about percent sentences. And before we jump into this, I want to look at what we've done earlier. In percent format for shape shifting with one number, we talked about going back and forth between percent and decimal and fraction format. This was mostly because our calculators don't do well with the percent format, and many calculators don't do well with fraction format. So if we know how to make everything decimals, it works better. Then in the Mad Science, squishing numbers together, we talked about things that started out with percent of, what is 58% of 300. And we talked about percent change. A item on sale went from $300 to $250. What's the percent of the change? So now we're going to make that kind of general, just like the fractions we did, took some of the things that we could have done with other ways and said the proportion is actually the nice way to do lots of these things. Then we're going to have percent sentences be kind of the general way that does the percent of and the percent change and other things too. Because if we just have one process we can always use, that's nice. We don't have to memorize lots of different processes and figure out when to use them. So a percent sentence is the simplest kind of word problem that involves percents. And we'll also see that if I give you a hard word problem, you want to first translate it into a percent sentence. So it's a step, a tool to use for hard things, as well as its own kind of small thing. And I'm going to make it smaller so it fits on the Jamboard nice. And stick it on the Jamboard. So a percent sentence is a short word problem and it includes the words is, of, what, and percent. Is, of, what, and percent. And we can think about these a lot. So what is 50% of 400? 38% of 27 is what? Right? Things like that. All we have to do is like pick two numbers and smash these words onto them and kind of make a sentence out of it. So here's 3 examples that we can look at more carefully. What is 35% of 60? 12 is what percent of 5? 5 is 2% of what? Sometimes we know what the percent is. Other times it asks us for the percent. Sometimes a what comes in the beginning. Sometimes a what is in the middle. Sometimes a what is at the end. Right? So we can have this all sorts of different ways. Everyone okay with this intro so far?
Yeah.
So there's no context. There's no real life situation. I'm not talking about prices or miles or anything. It's just numbers, a percent, a what, kind of stuck together. So there's 2 ways to deal with these. And I will show you both on the same slide. As I've often said before in this class, you don't have to reproduce yourself both ways. I'm pretty sure that never in your life, including the GED, will anyone say that you have to do this kind of problem this way. But you should be able to follow both ways, because a teacher might use either of these in your next math class. Or a test might say, here is a problem that someone did most of the steps correct, but made a small mistake. Can you fix their mistake? And you have to understand the method they used to do this. So we're going to do the same problem 2 different times. What is 35% of 60? In the translate method, I just take all of these things and I translate them. And this is something you've seen before with lots of other types of math problems. What do I change the word what into when I want to make an equation?
Y.
My y or x or whatever letter. I happen to like y. Is becomes what?
Equals.
Equals. Is always equals. What's the other word that we translate here? Of becomes
Multiply.
multiply, just like in the percent of that we did before. We want to take any percents and turn them into decimals because our calculator likes that best. We're going out of percent, so left out of percent. So that's going to be just 0.35. And 60 doesn't really need translating, it's just a 60. And when I solve this, 0.35 times 60 gives me 21. Everyone okay with the left-hand side?
Yep.
So what we got was is becomes equals, of becomes times, what becomes our y, and I guess I should make a dot because I made a dot above, huh? You know, that's multiply. And then if there's a percent, then we're going to need to do riplop. This is a slightly more complicated way for what we talked about as the percent of, where you take the percent, make it a decimal, and then multiply it. We've done these problems before in the mad science section. All we're doing now is putting a y equals with the what and the is. However, if the what was in a different place, then it will start looking different. So that again, this is a system that you can always use no matter which kind of problem. And it's nice. It does not only the ones we've done before, but other ones too. Okay, I need to pause just a moment. Okay, the proportion method is a little confusing. It's kind of like riding a bicycle. If you haven't seen it before, which you probably have not, then it will seem a little strange and you need getting used to it. However, it involves cross multiplying, and some students love cross multiplying more than anything else in the math class. And if I say, here is a way to cross multiply in a different kind of problem, they are like, yay, I love cross multiplying. Let me at it. So I'm going to go through all the steps. And again, I'm going to write them at the bottom in red when I'm done. First, I'm going to draw fraction bar equals fraction bar. Which I will just call the skeleton of the proportion. Then, and let me double check on this one because I was asked to teach it a different way. Yes, the left side we're going to put the percent over 100. So one of these things will be our percent. And the other, we're going to just use the number 100. So what's the number, what's the percentage in this one? It's 35%. 35%. So that's going to go here. And then we just put 100 because we always put 100 in the bottom left. Then bottom right, there's something that comes after the word of. I can't end an English sentence with the word of. It doesn't work. There has to be something after the of a number of what. So what comes after the of this time? Of 60. So my 60 goes there. And then lastly, on the top right, there's whatever's left over. So what have I not used yet? I haven't used my what. So that's what goes up here. Once I've done that, then this is just a proportion problem. I don't really have room to use all my colors, I'm sorry, but y times 100 is 35 times 60. Divide both sides by 100. And I get y equals 21. Notice there's no riplop. I will put it in like big lipstick. No. Why is there no riplop? Can anyone explain that to me? I'll give you a hint then. What does the riplop do? It changes the percent into something else.
Decimal.
A decimal, because the percent symbol and two scoots mean the same thing. So I can replace the percent symbol with two scoots. In this one, what did I replace the percent symbol by?
Over 100.
Over 100. So since I did that, I'm done. I don't need a riplop. I've already replaced the percent symbol by something. So let's do a whole bunch of these. Ready?
Yeah.
I will grab my labels. And the next one is 12 is what percent of 5? Before we start, is our answer going to be bigger than 100 or less than 100?
Bigger than 100.
Yeah, it's more than 100% of 5. Because what's 200% of 5?
10.
10. It's going to be even bigger than 200%. So we can kind of stare at it and get a sense of what's a reasonable answer. Okay, I'm going to do both. be able to follow me, start thinking about which one you like better if it was you doing this on homework. 12 stays 12, becomes equals, what becomes y. The word percent, we don't translate to anything. You'll see what happens there in a moment. Of becomes multiply, 5 is a 5. I have y times 5 equals something. How do I get y by itself?
Divide by 5.
Divide by 5. To peel off a times 5, I have to do a divided by 5. And if I do it to one side, to be fair, I do it to the other. So y equals 12 divided by 5. And I get 2.4. And that is a good answer, but it's not the answer I want. What's my last step?
Riplop?
Riplop. It asks for a percent. So now I'm going to go into percent, right into percent, and I get 240%, which is more than 200, just like we said, is y. So that's where the word percent comes from. If they're asking for the percent, we're going to have to do a riplop at the end to get that percent, but we don't translate it in the beginning. So that's nice. This isn't that hard, and it does a different kind of problem than we could do earlier using only our mad science tools. Here we had to do the same thing to both sides of the equation. It's a justice topic chapter. Questions about the left side before I do it in the proportion method?
No.
Okay. Proportion method. So I make my skeleton, fraction bar equals fraction bar. Who remembers what goes on this side?
Percent over 100.
Percent over 100. I don't know what it is. That's my letter this time. What goes in the bottom corner?
5.
Yeah, of something. The 5 is of something. And then the thing we haven't used yet?
12.
12. Now, no, I'm not going to say that. Okay, so then I do my cross multiplying. Y times 5.
Rocks that I got this one. That's on the gunmetal.
12 times 100. And if I do 12 times 100 divided by 5, surprise, surprise, I get 240. Now my answer isn't 240. What's my answer?
240%.
I just put that percent sign on. Why? I've already paid for it. I put something over 100 already. So I'm going to make a reminder here. No riplop.
Watch the light and jump off if they want. You guys are all right. I think I have everybody. I think I have them all doubled up. Shuffle.
Okay, last one was 5 is 2% of what?
So the Tabitha you see is my cousin Tabitha, but then Tab, you are on here as a bestie. All right, 3 prizes.
Okay. I'm going to Ruthie for now. Okay. Somebody tell me what to do for these. Where do I start with the translate method?
Put the 5 underneath.
Yeah, I'm actually going to draw arrows because that's how I do things. Okay, 5 becomes a 5.
Equals
Is equal.
Is equal.
And then you do riplop to 2.
I do riplop to 2, right or left?
Left.
Left, I'm going out of a percent. So I'm going to get 0.02. Okay.
And then multiply by y.
Of is times, what is y? Okay. So I have something is something times y.
Then you're going to divide by 0.02.
Yeah, the thing stuck onto y is 0.02, so I'll do it to both sides. Y is still around, and 5 divided by 0.02 gives me 250. Does that seem reasonable as an answer? 5 is just a little bit of 250.
Yeah.
Yeah. If I got 10, I would be suspicious. No, 5 is like half of 10. That should be 50%. But yeah, 5 being just a tiny bit of 250, that makes sense. Okay, other way. What's my first step?
Percent over 100. So it'd
Not
be 2.
yet there yet. First, fraction bar equals fraction bar. Then I put the percent over the 100. No riplop, that's how I pay for the percent symbol, with an over 100. Okay, then.
And then y over 5.
Yeah, of what? Of what? The what comes down here, because that's the thing that's of. And the thing I haven't used yet is my 5. Then I cross multiply. I'm going to get y by itself with a division by 2. Tell me if anyone wants me to write more steps to these. I am being lazy and writing fewer. So y times 2 divided by 2 is just y. 100 times 5 divided by 2 will get me back to 250. Okay, let's take a vote. Who likes the translate method better so far? You're welcome to change your mind once you practice homework.
I think I'm okay with both of them.
Me too.
Anyone definitely a proportion method fan?
I am.
Okay, so that's that. Let's look at what it looks like in the lecture notes. The translate method, I tell you those things that I wrote in red on that slide a few slides ago. The proportion method, I tell you those steps I wrote in red, so that there they are. And there's videos. There's a kind of pattern with the what being first or second or third, but don't worry about that. If you try and memorize all sorts of rules, then you're going to make yourself do too much work. You'll have too many things of, oh, what situation is this? Do I multiply here or divide by here and so on? So don't bother to figure out the shortcuts. They're not really shortcuts. It's also true that I can always rearrange things so the of happens before the is. It's legitimate English language, but it sounds a little bit too much like Yoda. What is 50% of 100? That's the same as 100%. I'm sorry, 50% of 100 is what? 50% of 100 is what? Or I could say 50 is what percent of 100? What percent of 100 is 50? Or 50 is 100% of what number? 100% of what number is 50? So you can always reorder things so that the of comes first. That just sounds a little more awkward. So this picture is sort of the summary of what we've done. Let's make it big and talk about it. Most of us have brains that really like the is to come first and the of to come after, and the percent is always in the middle. If we look at what we did, the is first, the of is last, the percent is in the middle, right? Is, of, percent in the middle. That's just the most natural way for the English language to work. So knowing that they happen in that order, it's like Mad Libs. There's a red blank, and that's the part, the change, the new amount. There's the percent, which is expressing the same thing, but as a percent. How much of the whole circle? How much out of 100 is this? And then at the end is the whole thing, our baseline for comparison, our original amount, something like that. So if that helps you, then great. That does mean that if I'm looking at the proportion method, it's always going to be my percent over 100. And the thing that comes after of, that's my whole original or baseline amount. Whereas the thing I haven't used yet, that's going to be my part or my change or my new amount. So once we start doing word problems, then you can just sort of jump right to that. Okay. Skip that complicated thing. Okay, we'll go back to those later. Because of time, I want to do a couple word problems because I know some of you will really want to rush ahead and try a word problem. And if this is too much for one night, that's fine. I am not pretending that we're really talking about word problems for a real amount of time. This could just sort of sit in your brain to percolate, so it makes more sense next time. So if I give you a real paragraph, somebody's car can drive 396 miles on a full tank of gas, but he only has 15% of a tank. How many more miles can he drive before he runs out of gas? So I want to change this into a percent sentence. Something is something percent. Actually, let me just copy and paste it from the previous slide. There we go. That's more efficient. So tell me what goes in the three blanks. I'll give you a hint. This one's usually the easiest.
15%.
That one's the 15%, right? It has a percent symbol on it. There we go. So there's a what and there's a 396. Are we asking what is 15% of 396? Or are we asking 396 is 15% of what? Is our 396 our part, our change, our new, or is it the whole, the original, the baseline?
What's the whole?
It's the whole. So the 396 goes here and the what goes there. And other than that, it's just what we've done. Pick whichever method you want and solve it. If you're doing the proportion method, then just like we said on this other slide, I don't even have to write my percent sentence with what is and of. I can just say fraction bar equals fraction bar. The percent goes on this side, 15 out of 100. Then for this one, what's my whole, original, or baseline?
96.
That's the 396. So I'm going to put that here on that side. And what's my part, my change, or my new? That's going to be my what? So setting up either one of these isn't terribly hard. It's just like Mad Libs, which things go in which spots, which things go in which spots. And that's really all I want to say, because I don't want to start the word problem lesson. But if you are a gung-ho person and wants to try this before Thursday, now you can, because that's all you do. Put things in the right spot and then go to it, just like we were without word problems. Okay, what I would rather do is say, oh, look, videos and textbook problems. If you wanted to rush ahead and do the homework, let's see what this looks like. We have some of these without word problems. Something is percent, right? Has a what, is, and of. This one has the word number in it just to confuse you, but that's okay. And then we have word problems. So that's all that happens. Some of these might have a tricky thing at the end, maybe. The random problems have the plain percent sentences and the ones with word problems. Let's do one more from these random exercises before we take our second little break. Which one do you want to do from A, B, C, D, or E?
B?
B, okay. Okay, so 373.6 is what percent of a bigger number? 934. Is our answer going to be less than 100% or more than 100%?
Less.
Less. The whole 100% is 934. This is smaller, so it's less. Okay, translate. So 373.6 is becomes equals. What becomes y? Of becomes multiply. and 934. On the other side, fraction bar equals fraction bar. The percent, I don't know. What percent? The thing after of 934. The thing I haven't used yet, 373.6. And that one's set up too. Okay, you finish this whichever way you want, and then I'll check in a moment. For the translation folks, how did you finish solving the problem? Something is y times something else. Are there no translation folks? Is everyone proportioned?
I did the other one, but I can do this one for you.
Okay, tell me.
You divide by 934 to both sides.
Okay. So 373.6 divided by 934. If I didn't make a typo, it's 0.4. Then it asks for a percent.
So you do rip lop. And go right.
Okay, yay, thank you. Proportion people, somebody else tell me what you do here.
Y times 934
Okay.
equals 100 times 373.6. Divided by 934.
Proportion folks will get 40 without any need to do riplop. Just put the percent on like a label. You've paid for it already with the over 100. And you're done. Check your work. Did you line things up so the equals and the y's are all lined up nicely?
My lining up sucks, so no.
So practice that, work on that. It will help you avoid careless mistakes and make it easier to review before. It is.
They're fighting.
It's surprising, especially when you get to level D and E math. How much math is just everything lined up, then it works better.
It's time to take that outside.
Ready for 8 o'clock break?
I will.
I think
Yeah.
so.
Okay, number 7 in the fractions exercises or percentages?
Fractions.
Fractions number 7. Okay. It's estimated that a driver takes, on average, 1.5 seconds from seeing an obstacle to react by applying the brake or swerving. How far in feet will a car that's going 85 miles an hour travel before the driver will react to the obstacle? So I want to do fraction bar equals fraction bar. What is one situation that I'll put on my left?
Would it be 85 miles over 1 hour?
That's a good place to start. We might want to change that later. But yes, those are the two numbers we have that go together, the 85 miles per 1 hour, right? Now I'm going to try and make the other thing happen. How far in feet? So this is a problem. We want the miles and the feet to match, and they don't. So do you want me to change 85 miles into feet? Or do you want to get an answer in miles and then as a step at the bottom, change it into feet? Both can work.
Can we change it to feet?
Change the 85 miles to feet? Sure. So I will say 85 miles. There's 5,280 feet in a mile. And then whatever that is, that's how many feet we have here. So 85 times 5,280, 448,800. Okay. And how many feet? Okay, that's up. Finally, 1.5 seconds. Seconds isn't matching. So again, I have a choice. Either change the hours into seconds, solve for hours, and at the end, change it into seconds. Which do you want?
Change the hour to seconds.
Okay, so I will erase the 1 hour. I'm going to make it seconds. And whoops, nope, not there. Per hour. So 1 hour times 60 minutes in an hour and 60 seconds. If you needed to write more than me, you can. I'm just sort of squishing it at the top. So 1 hour is 3,600 seconds. Then the other situation has the 1.5 seconds. So this situation is the speed of the car, 85 miles per hour, but we've changed both the 85 and the 1 to something else. The other situation is eek, screech, brake, right? I have 1.5 seconds and I'm not sure how many feet. And that was the hard part. I bet you could finish it up here.
Yeah, I can. Thank you.
So that one. I will just draw this much and then stop. And if anyone needs me to finish this as a transition on Thursday, we can certainly start with this. And once more, if you needed more space to write this, because this is actually like a unit analysis kind of thing or a proportion thing, then you certainly can. I just squished it up because that wasn't really the important part. Okay, I'm going to stop the recording.